Hey TechKnowStuds, let's talk about wireless, really cool technology and how it works and gives us a lot of freedom. In this video, we're going to talk about how wireless works, some advantages and disadvantages of wireless. Then I want to make sure that we are on the same page as far as equipment is concerned. There's a couple things that are misconceived out there or errors that I've seen people make. Let's talk a little bit about standards and some standards that are out there, and then we'll wrap this up talking about the two main frequencies that we use and the advantages and disadvantages of those two frequencies. In my last video, I went into frequencies and amplitudes and how it gets sent across through the air and how we send it and receive it. From this perspective, I'm just going to briefly mention how we get data from one side to the next. So one way that we could do that is we can send a frequency out, but we can vary the amplitude to be able to send data from one location to the next. So depending on what the amplitude is, then we can either measure that it's a 0 or a 1 or whatever data that we're trying to transmit across. The other option that we have is we can vary the frequency. Now, this is interesting because we're picking up a frequency and we're reading that frequency. So what we have is we actually have a little variation. It's a really small, minute variation of that frequency will allow us to determine is that a 1 or 0 or whatever data that we're transmitting across that line. So really we have these two methods to be able to send data over. We have AM, which is amplitude modulation, or FM, which is frequency modulation. And that's how we get data from one location to another. So what are some advantages of wireless? Well, one of them is just the coverage area. I can stick a couple wireless access points up and suddenly I've got this really wide range and I don't have to sit at a specific desk or a specific location wherever the network jack is. I can be free to move around. So really mobility, I can really move this around. This is largely why we associate wireless with laptops. Of course, I've seen some PCs that have motherboards with wireless built in as well. Another thing is cost. If I have to wire up a bunch of jacks all over my office to facilitate people's needs and then have all those jacks live, that could cost a lot. Whereas if I put up a wireless system, it potentially could save me a lot of money for that. So the cost could be significantly less with wireless. There's also the ease of installation. I just need to, for wireless, run a few connections up in my office and put the wireless access points up. And then I don't have to wire up a huge office and have these big runs everywhere and have all these patch cables. And I don't have to manage all of that. So it's really easy to install and manage. Then another thing, I'm going to add this, and probably a lot of people will disagree because I'm also going to add it into the disadvantage, but that is security. You know, with wireless access, it is insecure in nature. So because of that, we put in a lot of security in there to secure our wireless networks. And so there is a lot of just out of the box security that happens when we're talking about wireless connections. Things that we could implement when we have a wired network, but we often don't have that because you have to physically connect into that connection. So I'm going to add security into the advantage area of this, but I'm also going to add it into the disadvantage. All right, so what are some of the disadvantages? Well, for one, the security, as I mentioned before, the communication happens out in the wild where anybody can pick it up and be able to read that traffic. And so you have to encrypt that traffic. And so security is a concern anytime with wireless. And we have these wireless standards that encrypt the traffic, but over time, those encryption standards get broken and people hack systems. And so whatever security we implement now is not good enough for the future. We're going to have to change it into the future. Another thing is it's a shared medium, which we're going to talk about in a second, which is not the greatest. And then there's a lot of interference. We talked about interference with copper and how other signals can interfere with this copper line, but there's some ways that we can combat that. With wireless, it's really hard to protect yourself from all of the signals that are coming in. And so any kind of interference that is out there can hinder your communication and hinder your two devices from talking. So one of the big disadvantages to wireless networks is the fact that it's shared. When we have connections to every single device, we used to have hubs in the middle, which means that whoever could talk, and we would have collisions, and there would have to be back-off algorithms, and it was not an efficient method. Now, most of our networks have gone to switches, where every line to each device that you have out there is a separate line, and we can have duplex communication, and multiple things can be talking at the same time. We got buffers on the switches, so it will capture that data and then send it out when it's ready. We just don't have that with wireless. We go back to the hub method with wireless. That is, whatever device talks, any other device can talk at the same time, and we have a collision. And that's a problem. We have to be able to deal with that collision. It's very inefficient. Not only that, but since it's shared, you're communicating. Let's say somebody is sitting out here in the outskirts at the very edge of the network, and everybody else has a strong connection and is communicating really fast, and this device is on the outskirts. There's a couple things that's going to happen. Number one is this device is going to have to slow down to talk to this device, and all other devices are going to have to wait until that communication is done before somebody else, another device, has a chance to talk. So that is one of the problems. Another problem with this device that's sitting out here in the outskirts is when it is communicating to this device, then one of the devices on the other side may not understand that this communication is happening, and in the middle of it all, ask to speak and say, hey, can I talk? And cause a collision, causing this device to have to start its communication all over again. Shared media is not a great way to go. And for this and for some other reasons, I find that wireless networks are a little shaky in how they operate. Sometimes they work, sometimes they don't, and it all depends on the weather and what kind of devices you have and what barriers you have in between. And it's just so much different variables involved with with these wireless networks. They're really cool and they're really easy to implement when they work, but then they cause problems these other times. So it's not always a great way to go, and the cost that you save in setting it up could be a detriment when it comes to productivity because you're struggling with all of these wireless connections. So it is the day and age we live in. We're going to have wireless from here on out. It's just convenient. And in fact, my last network I primarily set up with all wireless, so you could be anywhere in the office and have connectivity. But I also made sure that there was some capabilities that people could plug into a port if they needed to, because it can be a little bit unstable at times. All right, a note about equipment. What I see a lot of times out there is people will go out and buy a wireless router, set it up on their network, and then possibly have problems or not even realize that they're running inefficiently. So a wireless router is not a wireless access point. Those are two different things. So what I'll see is they'll have some sort of a wireless router on their small business, and it connects all the devices up there, and then they want to have a little stronger signal in a section, so they'll go buy another wireless router. And what happens is this device out here gets put on, let's say this laptop is connecting to this wireless router, and it is now on a separate network than everyone else is on. So it doesn't have the same communication ability as the rest of the network. You may or may not want that, but probably not. It's probably by accident. So be cognitive of if you put a wireless router on your network, and maybe it is that you actually want a wireless access point instead. A wireless access point is just a layer 2 device. This is a wireless router is a layer 3 device, so it actually does some routing and some NATing on it, versus this access point just puts the client, when you're connected to it, puts the client directly on the network. Then the nicer networks that I've seen, or usually it comes with bigger businesses, is they have some sort of wireless LAN controller, something that's sitting on the network as well. And so this can work in two different methods. Number one is it could just be a way to program your different wireless access points. One single management console, so that way you can manage your wireless access points. But I've also seen, actually more often than not, is these wireless access points will tunnel the traffic. And when I say tunnel, that means it will take that data and encapsulate it as if its own, send it through the system, and then send it back to this wireless controller. The wireless controller will then unpackage it and say, okay, what do I need to do with this? And dump it on the proper network. And so possibly it's right here onto this switch, or maybe it's another switch, or maybe it's out to the internet. And this way it can implement some security frameworks, such as I can have a guest wireless system that never touches the rest of my LAN. And there's some other features that are really cool about it as well. So that is a wireless controller. A wireless controller just helps you manage your wireless LAN. All right, let's talk about some different wireless standards. One thing that really pops into our mind when we think about wireless is Wi-Fi. Our Wi-Fi is defined by IEEE 802.11. There's a lot of different standards underneath there. We keep adding to it because we keep coming out with better ways of doing this and faster ways of getting information to people's machines and things that are more stable. So we've come a long ways with this, but that is one of the standards that's out there. Another one that you're probably familiar with is Bluetooth. We've got IEEE 802.15. 802.15 has our things for, like, my mouse is Bluetooth and it connects to my laptop. And then there's also things like my Bluetooth speaker. And so there's a lot of personal area networks that are created. A PAN, a personal area network, that's between those Bluetooth devices, and it creates some sort of local network between those two. Then we have something like Zigbee, which is very similar to Bluetooth, and it's more designed for like Internet of Things or smart home stuff, home automation. And it creates this little mesh network, and then you can link things together. And so it is a network that's created from these smart home devices. And then you've got something like WiMAX, and WiMAX is a metropolitan area network, a metropolitan area. So somewhere within a city, they have a mesh network that you can connect to and get internet service providers. So there's lots of different standards that are out there that allow some of this wireless communication to happen. All right, there you have it. We talked about wireless. We talked about how wireless works. We also got into some advantages and disadvantages that wireless has over other media. We talked about some of the equipment, the difference between a wireless access point and a wireless router. And then we also talked about the wireless LAN controller. And then finally, we wrap things up with the standards. Thanks for watching my videos. If you like them, could you hit that like button? Because it really helps me out.